everyone, welcome to Standard 8 Physics class. Today we are going to discuss about the chapter sound. In this chapter we will study about pitch and frequency of sound, difference in pitch of different musical instrument, loudness and amplitude. So let us begin the topic by discussing pitch and frequency. We know that sound is a longitudinal wave and sound waves move in a medium as a series of compression and rarefaction. So what do we know? Sound is a longitudinal wave and sound waves moves in a medium as a series of compression and rarefaction. Compression, rarefaction, compression, rarefaction. As a series of compression, rarefaction, compression, rarefaction, compression, rarefaction. Are the region where the particles are crowded together. What is compression? Is the region where the particles are crowded together. Rarefaction are the region where the particles are separated apart. So you see here, this is the region where the medium particles are crowded together. So this region is called compression, and this region, the rarefactions are the region where the medium particles are spread apart. Compression are represented by the peaks, that is the upper portion of the curve, and the rarefaction are represented by the valleys. These are the compression, rarefaction, compression, rarefaction, compression, rarefaction. That is the lower portion of the curve. Compression, rarefaction, compression, rarefaction. So if the peak of the curve representing compression is known as crest, the peak, this is the graphical representation of compression and rarefaction. Compression is represented by peaks and rarefaction is represented by valleys. Means compression is represented by the upper part of the curve, whereas the rarefaction is represented by the lower part of the curve, and the upper part of the curve is called crest and the lower part of the curve is called trough of the wave. That is the mean position of the wave. The upper part of the wave from the mean position is called crest, and the lower part of the wave from the mean position is called trough. This is called crest and this is trough. The lower portion is called trough of the wave. If we count the number of compression or rarefaction that crosses a particular region per unit time, we will get the frequency of the sound wave. So frequency can also be defined as the number of vibration produced in 1 second by a vibrating body. So what is frequency? Frequency is the number of vibrations produced by a sound wave produced in a second by a vibrating object. So frequency is denoted by symbol small f, and its unit is hertz. SI unit of frequency is hertz. A sound wave with high frequency has more crest, and sound wave with low frequency is given. Low frequency wave is in a given period of time. This is the high frequency side. The sound wave with high frequency has more crest. You count the crest 1, 2, 3, 4, 5, 6 and 7. But in case of the sound wave with low pitch, It's low frequency will have less crest. You see, this is a low frequency sound. Compression and rarefaction of air molecule are perceived by the ears as sound. We perceive higher and lower frequency of the sound. We perceive higher and lower frequencies of sound as high and low pitch sound. The frequency determines the pitch, means shrillness of sound. For example, a whistle has a high frequency and therefore produces a sound of high pitch, whereas drum vibrates with a low frequency, producing a low pitch sound. This is a high pitch sound and this is a low pitch sound. In case of high pitch sound, you have seen the number of crest is more than the low pitch sound. In case of low pitch sound, the number of crest is less. Higher the number of vibration in a unit period of time, higher is the frequency and the pitch of the sound, and vice versa. Monotone. A continuously occurring sound which does not vary in pitch is called a monotone sound. So we may say a sound in which the frequency remains the same is a monotone. Change in pitch in our voice also expresses our emotions. A person listening to monotone cannot understand how the speaker is feeling. A monotone is the simplest music consisting of only one tone. An actual music which has many tones played out in a defined repeat sequence. Too many tones with no correlation to each other are perceived as noise. You see, this is the graphical representation of a monotone sound. In this case, the pitch remains the same. There is no change in the pitch. Means there is no change in the frequency of sound. But in music and noise, the frequency or pitch of the sound varies very frequently. You see, this is the graphical representation of music and noise, and find the differences between monotone and music and noise. Difference in pitch of different musical instrument. Music is the sound which we find pleasant to hear. Sound produced by piano, violin, flute are considered to be musical sound as these produce regular and periodic vibration. The instruments used to produce music are called musical instrument. The instruments which are used to produce music are called musical instrument. Some of the musical instruments are string instrument, wind instrument, and percussion wind instruments. So string instrument. In this instrument, sound is produced by the vibrating string. When the string instruments are sitar, violin. When the string are plucked or struck, they vibrate to produce a sound of specific frequency or a musical note. Some examples of string instruments are veena, sitar, violin. Frequency of sound is changed by changing the length or the lightness of strings. Tight and short string produce sound of higher frequency and hence higher pitch. On the other hand, loose and long string produces sound of lower frequency, hence lower pitch. Now, wind instrument. Wind instruments produce sound when the air is blown into them. Some examples of wind instruments are flute, whistle, and saxophone. The frequency of sound of wind instrument is changed by changing the length of the air column. The length of the air column of a wind instrument can be changed by either opening or closing the holes made on the tube. Long air column produces sound of lower frequency and therefore of lower pitch. On the other hand, a short air column produces a sound of higher frequency and therefore a higher pitch. Now, percussion instrument. Percussion instruments produce musical sound when the skin or membrane of them are struck. Some examples of percussion instruments are tabla, dhalak, and drum. Stretching of the membrane increases the pitch or frequency of the sound. Tight membrane produce the sound of higher frequency and therefore of higher pitch. On the other hand, loose membrane produce sound of low frequency and therefore low pitch. Now, loudness and amplitude. The magnitude of maximum displacement of each particle from its mean position is called amplitude. It is represented by a letter A and its unit is meter. It depends on the force with which the object is made to vibrate. The highest of the crest and troughs determine the amplitude of sound. This is the crest and this is the trough. The highest of trough and crest from its mean position represents the amplitude of sound. Both the waves of the crest, however, the wave of bigger height, this is the waves of smaller height. Bigger height correspond to high amplitude and louder sound. Bigger height correspond to high amplitude and louder sound. Whereas lower sound, lower height represent softer sound. If we strike Hello student, I welcome you again to Standard 8 Physics class. We are discussing about sound. Now we are going to discuss about loudness and amplitude. The loudness of a sound is directly proportional to the square of the amplitude of the vibration producing sound. Loudness of a sound is equal to square of amplitude of vibration. If the amplitude doubles, the loudness increases 4 times. The unit of loudness of sound is decibel and is denoted by small d capital B. The safe limit of loudness for human ear is 85 decibel. Decibel level of common sounds are given here. You remember this. To verify the loudness of sound depending upon the amplitude of vibration. So this is all about the chapter sound. So thank you very much for watching this video.